This is problem 15.5.46, and there is a professor at State College that is developing a regression model to predict final exam scores for students based on their current GPAs, the number of hours that they studied for the exam, the number of times that they were absent during the semester, and their genders. So we have some data here in the table, and I have not copied it yet. I'm just going to copy to the clipboard. Copy that there, and then come over to Excel, and then just paste it. Okay. All right, so all of our data is there. So score, of course, is our Y dependent variable, and then we have 4 different independent variables here with GPA, hours, absences, and gender. All right, so when we work through this problem in the lab, really just reveals one part at a time, which can be a little frustrating because you're not able to really look ahead and see when you're running a regression what else you might need. So sometimes with problems like this, you have to run more than one regression to get all the information that you need. Part A just asks for the variance inflation factors for each independent variable, so we can check for multi-collinearity. It mentions here, as you can see, to use an Excel add-in like PHStat. So PHStat, as I've said in other videos, is a Excel download, just a file download that was used previously, but now we are using XLStat for the current course. So to find the variance inflation factors, we need to use XLStat, and with this we can just run a basic regression of our dependent variable, that's score, and our independent variables here. And so, as I said, we can just run a basic regression. It doesn't have to be best subsets or stepwise or anything like that. It'd just be a basic regression. I have confidence interval of 90 in here right now, which turns out later in the problem for this particular question, that's what it's going to end up asking for based on part C. And our levels needs to match our number of independent variables. So in this case, we have 4. We need to adjust that. And that's pretty much all that we really need for part A to get the variance inflation factors as far as the general menu and the options menu. Do need to, of course, go over to the outputs and make sure that we have multi-collinearity statistics checked, which we do. And for this, make sure there's no chart selected. So very simple. After we run this, if we need to get more information, we can just delete the sheet that the output is generated on and rerun the regression, or we can have work with multiple sheets and just kind of show the progression from one step to the next, just kind of depending on what the problem is asking for. All right, so you can see here that actually the first thing that XLStat supplies us with is the VIF statistics. So you can see here that they're all well below 5, which is used as kind of the benchmark for our textbook. There are, kind of depending on the text or the researchers, a couple of different benchmarks for VIF. There's not really one particular figure that's agreed upon across the industry. Sometimes you see VIF scores of 10 or less being acceptable, and sometimes there's certainly researchers that say that if you have even a little bit over 10, it can be acceptable for certain models. So for our course, for our textbook, we are working with a kind of a benchmark hurdle of 5 being below 5, which all 4 of these independent variables are far below that figure. So we're good there. The question asks in part A if there is any multi-collinearity, and of course we're saying no because all the VIFs are none of the VIFs are greater than 5. And skipping down to part C, here's where we find out we need to perform a general stepwise regression and using an alpha of 0.10. And it gives us for the p-value to enter and remove independent variables from the regression model with that alpha. So now we have a couple different options. We can just rerun it and have the output go into a brand new sheet. which is fine, or we could delete the sheet that this generated on and replace it with a new one if we want to, if we're trying to kind of create a solutions file or template. In this case, I'm just going to kind of leave it as is and just we'll just add a separate sheet with our new output. I'm going to go back to the linear regression box here, and we'll just update a couple things. So we know now that instead of just a basic regression, we need to run a stepwise regression. So we'll select stepwise, and probability for entry is already at 0.10, probability for removal already at 0.10, so nothing that I need to adjust there. And we can leave the output to include the multi-collinearity statistics enabled there, it's fine. And we can also select residuals and take a look at those and see what we get. Okay, so based on the stepwise regression, of course we have our multi-collinearity statistics here that we ran the first time since we left the box enabled. And here's where we have some results from the regression. So as you can see, we've got, first the system started with GPA, and then it added hours to the model. So those are really the two variables, independent variables that fit the model, that was the best result from the stepwise regression. So that really is our actual model. And if we scroll down to the model parameters at the bottom here, you can see that's where we have coefficient results for those two variables. Absences and gender, since they're not included in the model, that's one of these are 0. So when we are building our multi-regression formula equation, you can see here for part D, we've got the intercept figure of 50.9. We have our coefficients for GPA and hours, and then we have 0 for absences and gender. Now, in reality, we would not include these two as part of the equation. This is really just merely to show you that they weren't a part of the model, that their coefficients are 0 because they were not included in the model. When we're actually writing the regression equation, we wouldn't include these as part of the actual equation because, once again, they're not actually ending up being part of the model. Okay, and then here is the regression here as it would actually appear with the y-intercept, GPA, and hours. And finally, we clicked on the residuals box just to show you that we could get the residual statistics for the model as well.